Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue with triangles and constructing angles, or rather constructing triangles on page 112. Yes, I have something on my face. It's a nasty fever blister that I'm trying to cure. In case you were wondering. So let's start with constructing triangles. Okay, so before we get into that, let's look at the key words that we have. So equiangular triangles. That means the angles are the same. So equiangular triangles have three pairs of equal angles. Okay. Similar triangles are the same shape as each other, but not the same size. They have identical angles and their sides are in proportion. Okay, so if we look at the diagram on page 112 in the textbook, the triangles on the left are similar, okay, because they have the same angles, but they don't have the same sides. Congruent triangles are exactly the same in every way. So they have identical sides and angles, okay? So if I have two triangles, let's say one that looks like that with sides 2, 3, and 4, and I have another triangle that looks like that with sides 2, 3, and 4, these two triangles are identical because, yes, this one has just been put on its side, but the sides are all the same sides. Okay, so that means that the triangles are congruent. And then we have an exterior angle. So an exterior angle, if we extend one of the lines past the angle, like here, here, this is known as an exterior angle. Okay, so we extend one of the lines. That exterior angle is the sum of the two interior angles. Okay, so any exterior angle of the triangle equals to the sum of the two interior opposite angles. Okay, but don't worry about that. We'll get to that as we move along. All right, let's first look at the first example. Okay, so they want us to construct a triangle PQR with PQ equals 9 centimeters, QR equals to 6 centimeters, and PR equals to 7 centimeters. Okay, guys, there's a really quick and easy way to construct triangles, okay? So what we're going to do is we're going to pick one of these sides and we're going to draw a line, okay? So I'm going to pick the longest side, which is PQ equals to 9 centimeters. So remember, how do we draw lines? You draw a faint line, right? And then on that, with your ruler, you measure 9 centimeters, okay? So there's my 9 centimeters. We mark off these points. Okay, and we can call them PQ. Okay, so that's P, that is Q. Right, so you only need to measure one of the sides. Once you've measured one of the sides, what you're going to do is you're going to take your compass and you're going to open your compass to the length of one of the sides. Okay, so let's look at what they've given us. They've given us PQ is 9 centimeters. I'll write it over here. Okay, we have PQ, we have QR 6.5. Okay, and the last one is PR 7. Okay, that's what we have. So we've already drawn PQ. Now we want to do QR. Obviously Q is here, and the other point R is going to be somewhere on the board that we need to find. So what I'm going to do is I'm going to take my compass, open it up to 6.5 centimeters. Okay. I'm going to go to one of these letters, Q, which is that there. We don't have R yet. We only have P and Q. So I go to Q. I measure 6.5 on my compass. I put my needle point into here, and I make a mark with my compass like that. Okay. Now you're going to go to PR. Open your compass to 7 centimeters. Find one of the letters. There's your P. Obviously, the R must be there. So put your compass to 7 centimeters, put your needle point in P, and make an arc like that. Okay. Now, where these two arcs join, that's your other point of the triangle, which is R. Now, what you're going to do is you're just going to take a ruler and you're going to join that, and you're going to join that. Guys, when you are doing these constructions, I don't want you to erase anything out, okay? I want to see these arcs. I want to see this line, this faint line that you drew. Okay, so the workings, that's part of your workings. Like you show me the steps, this is your steps. Okay. All right, cool, guys. So that's how we would draw any triangle. If I've given you the distances, again, draw one of the distances on a straight line, label it, then go to each point, make an arc with that particular distance, make an arc where the two arcs meet. That's your other point of the triangle. Okay. Cool. Number 2, it says extend PQ to B. Okay, so we have B on the right, so I've extended it to B. Here's my B. Okay, and then they say QP to A. QP to A. Okay, there's my A. And they want to extend QR to C. QR to C. Okay, there's my 3 extensions. Great. Right, what do they want now? Show that each exterior angle is equal to the sum of the interior opposite angles of triangle PQR. Okay, so what they're really saying is that show that each exterior angle, remember, exterior angle of a triangle is if we extend a side, then this is an exterior angle. This is an exterior angle. And that is an exterior angle. Okay, so those are 3 exterior angles. They want us to show them that this exterior angle equals to the 2 inside opposite angles of the triangle. Okay. Same thing with this one. They want us to show that that equals to this plus this. And that equals to this plus this. Okay. So here they didn't say anything about not using a protractor. Remember, I'll tell you when you can't use a protractor. I'll say construct angles without the use of a protractor. But otherwise in geometry, we're allowed to measure angles and use that. I don't want you to bisect any angles like we did before because we simply don't know a single one of these angles. They weren't given to us. So there's no point of slicing these angles in half and into quarters because we don't even know what that hole is. Okay, so what we're going to do is you're going to put your protractor here on each one of these points over there, and you're going to measure these angles. Okay, so there's a shortcut. Instead of measuring each one of these individually, what we're going to do is we're going to measure this all in one go. So we're going to put our protractor over here, right? Imagine I have a protractor like that. I put it down. So what I'm going to do is I'm going to measure this angle here, this exterior angle on my protractor, and obviously look on the scale as you go up, read that angle. So I've measured it. In the textbook it says it is 134. So this is 134 degrees. Okay, but guys, I want you to actually measure these. Don't just follow me around. Do these in your book. Practice this because geometry is about practice. All right, cool, guys. So we've measured 134. But now, keeping your protractor in that same spot, measure this angle as well. Because now you can go to the 0 on this side and measure up to that line. Okay, so you could do that. Or you could even think that, well, angles on a straight line add up to 180 degrees. If I already know that this is 134, well, this must be 180 minus 134, which is going to be 46 degrees. Okay, but since you're already measuring it, you can do it in one go. Just read that reading. Both of the numbers are there in that one line when you put your protractor. So you can do 2 at once. All right, cool. Let's go here. We're going to do exactly the same. Put the protractor there and measure. So this is now 51 degrees, and this is going to be 129 degrees. Okay, and then the top one is 97 and 83. Okay, so all that we've done is we measured these angles. We haven't shown anything that they asked us for. They are now saying that show us that this angle equals to those angles. Okay, So the way we do that is we're going to say that, well, angle APR. Okay, angle APR. Guys, remember the three-letter notation. APR. Okay, that's the angle. So you want to draw out the angle with three letters of whatever you're doing, right? So if, let's say, I need this angle 83, well, that's that angle there. Let's follow the letters. P, R, Q. And always the little hat cuppy thingy goes onto the middle letter where the angle is. Okay. So APR equals to 134 degrees. Okay, we know that. There it is. We measured it. Cool. Now we're going to say that, well, this angle plus this angle equals something. So let's do that. So PRQ plus this angle PQR equals. Okay, what does it equal? 83 plus 51. And we're going to add them. I'll do it over here. We're going to get 80 plus 50 is 130 plus 4, 134. Okay, well, look, that's also 134. But now we need to say that they are equal. So we're going to say, therefore, angle APR equals angle PRQ plus angle PQR. Okay, so that's how you show that something is equal to something else. You show me that one thing that we need to show is equal to the value. Show me the other two angles equal to the same value. Now you can conclude by saying that yes, APR does equal to these two because they both equal to the same number, 134. Okay. So guys, you're going to do that for the other two, or actually they've done it for you in the worked example. So the workings are there. So they've done exactly that. They show you the two angles and then they add them up. Okay. Right, the next one is determine the sum of the three exterior angles. Okay. And this is quite interesting that you'll find that they always sum up to 360 degrees. Okay. So I'm just going to erase this. Let's keep the drawing. Okay. Right, so I'm going to use their answers, and their answers are 134 degrees because I haven't worked out the other ones, but I guess, well, actually we have the three exterior angles there. So let's add them. We have 134 plus 129 plus 97. Okay. 9 plus 4 is 13, plus 7 is 20. 0, carry the 2. 2 plus 3 is 5, plus 2 is 7. 7 plus 9 is 16. 6, carry the 1. 1, 2, 3. 360 degrees. Okay. Guys, it's another result that you need to know, that exterior angles of a triangle add up to 360 degrees. Okay. Right, now what you might be thinking is that, well, wait a second. There are not only three exterior angles, but there are six exterior angles, right? Because, well, look, we've extended that line, but what if we extend this line over here? Is this not an exterior angle of a triangle? Okay, this angle here. And the answer is yes, it is an exterior angle of a triangle. And this exterior angle also equals to 134 degrees. Why? Well, because they are vertically opposite. And this exterior angle, we need to sum up both of those, which is the same for that. So really, it doesn't matter which exterior angle you pick of a particular vertex of a triangle. They will be exactly the same. So that's why we'll say when you add three different or three exterior angles from each vertex, then we're going to have 360 degrees. Okay, we can't say that plus that plus that is 360. No, we're going to have one from each vertex. Okay. All right, cool, guys. So that is our worked example. Let's now look at the next example. Okay, so the few lines that are written above the example, they're basically giving us conditions for congruency. And congruency means that the triangles are exactly identical. So if they told us that they have all the sides are equal, let's say they give us two triangles with different sides, different letters, but the sides are all the same size. Those two triangles will be congruent, meaning they'll be identical. Okay. And if we have the second example where they tell us they give us two sides, which are two lengths, and an angle in between, then if we draw another triangle with different letters or turned around, it will be identical to the same triangle. Okay. But what they're basically doing is they're building this up, and then at the end they're going to tell us, oh, okay, these are our congruency conditions. Right, but anyway, let's work through this. So the next example says, construct triangle ABC with AB 13 centimeters, angle A 47 degrees, and angle B 19 degrees. Okay, so here they've given us two angles and a side in between. Okay, not two sides and an angle, but either way is a congruency condition. All right, cool. Let's continue. So we need to construct a triangle with AB 13 centimeters, and they tell us that the two angles on A and B are 47 and 19. Okay, so step one, we're going to draw our straight line, our faint straight line, and then we're going to measure on that AB, which is 13 centimeters. Okay, and we can make it dark. Now, guys, when you're making these lines dark, okay, I don't want you to like go over it a gazillion times to make a hole through your paper, okay? You just literally go once normally and twice back. That's it. Two times, not pushing hard, just once, twice. That's your solid line. Your construction line, you almost not pushing on the pencil. So if you imagine the pencil is just barely hanging on your pen and you drop it on your paper and you drag it across, that's how faint your construction lines should be. So when you're drawing it, when you put your ruler and you're drawing your construction line, you're just dragging it across. You're not pushing on it at all. When you're doing the solid lines, you're pushing a little bit and you do it twice, okay? Or you can push a little bit harder and do it once. It's up to you. All right, cool. So we got AB 13 centimeters. Let's now look at, what do they want? Angle A is 47 degrees. Okay, so obviously now we need to use our protractor. They didn't say construct an angle. They said A is 47 degrees. So we're going to put our protractor over here. The center is going to go there. And remember, where's our angle? It opens up like that. 47 degrees is an acute angle. So you know it's only going to go about that high. Okay? So you're going to put your protractor here, start from 0 on this side, and go up to where it says 47. Make a little mark there. Now what you're going to do is you're not going to draw a solid line or a thick line. You're going to draw a thin construction line going up like that. Okay? You don't know how long that line is. We need to intersect it with the other line coming from the other side. Okay. Now we're going to go to angle B, which is 19 degrees. So that's over here. We're going to put our protractor again in the center at the point. Go to this side now and measure 19 degrees, make a mark. Okay. Then what we're doing is we're joining B with a thin line going across like that. Okay. Now that's given you the location of your third point, which is point C. So that is point C. Now you're going to take your ruler and draw a thick line over here and a thick line over there, like that. Okay, and now we are kind of done with this. What you can do is you can also put angles there. So this is 47 degrees. This is 19 degrees. You can also work out that angle because remember, angles of a triangle sum up to 180 degrees. Okay, we've done that. Number 2, extend AB to E. All right, AB to E. There's my point E. All right, BA to D. BA to D. There. And AC to F. AC to F. Okay, there's our extensions. All right. Okay, remember, when they say extend this line, that's not a construction line, it's a solid line. So this little bit is the construction, this is now solid. Same thing over here, this becomes solid, the rest of it is construction. This is construction. That is solid, that is construction. Okay. Right, and also they don't tell us any measurements here, so you just extend it a little bit. Like, don't go half a millimeter, make a little, a workable distance, because they'll probably ask you to measure an angle there. So you got to extend it far enough, or at least the construction line, so that you can place your protractor and read off your angle. Guys, you don't want to waste time with this stuff. You don't want to put your protractor, draw a little line, and then you're like, oh wait, my line's not long enough to read off the angle. So you either take a chance and approximate, or you now have to stop, extend the line. Now your line is a little bit off because you didn't make it a straight line. Then your answer is 2 degrees off, and then I have to give you a minus mark for that. Okay, so think before you do things. Extend the line longer so that it's easy to work with. Okay. Right, so what do they actually want? They say show that each exterior angle is equal to the sum of the interior opposite angles of the triangle. Okay, guys, exactly the same exercise as before. They want us to show that this angle equals to these two angles. Okay, same thing. What you can do is you can measure, or we can work it out, because we know this is 180 degrees, so this is 133 degrees. Okay, this is 47 plus 19, that's going to be 66. Then that is going to be 166, 114. Okay, I think that's right, yeah. All right, and now we just need to show, then the same way. You say DAC equals that. ACB equals that, plus ABC is that. They're equal to the same amount, 133, therefore they are equal. So guys, number 2 is literally rewriting the same stuff as I did in the worked example. I'm not going to do that. And number 3, determine the sum of the exterior angles. Same thing. Add up all the 3 exterior angles that we have. Show me that they are equal to 360, which they do. Okay, guys, so that is the 2 worked examples. So what we're going to do for this time, there is no homework, because I want to get through the next 2 examples, and then we're going to get into exercise 12.12. All right, guys, now for those of you that have different textbook, oh no, sorry guys, never mind, I'm talking about a different grade. So yeah, no homework for today. Enjoy it. Make sure you can draw these triangles. Please practice these worked examples. So go through this video again and make sure you can do this. Don't just watch me do it on the board. Take out a compass. Practice how to turn and measure and stuff. Guys, the hardest thing here is keeping your compass the same distance and learning how to work with it and how to measure accurately. Okay. Right, cool guys. I hope you enjoyed the video, and I'll see you in the next lesson. We'll continue with these constructions.